Hello and welcome to the part 2 of my astronomy video. This is my setup. I got my telescope, knee pad, lenses and stuff, and I wanted to show you what the stars actually look like based off the video of part 1, right? And before I showed you the stars, I wanted to put the coordinate system I explained in my last video in actual practical use, right? So I'm going to take you on a little trip, right? We're going to go all the way over here. Now we are facing north, so Polaris, might be kind of hard to see, is right here, that little dot. And declination is degrees from Polaris, right? So if I go here, I don't blame you for not being able to eyeball this, but from, let me locate it again. From Polaris, if you go all the way over here, right, taking a little trip, this is 0. That's 0 on the equator, right? And from here is 20 degrees. So Jupiter, that dot right there, is 20 degrees from the equator, right? Right, because if the equator is 0, then it goes 20, 60, 80, 90 from Polaris, right? So that is 20 degrees, and if I go back to Polaris, this is 0 hours, right? So 0, 6, 12, 18, 24/0. So if I go from here to all the way over here to 24, right? This is 6 degrees, 6 hours. So the coordinate of Jupiter is 6 hours and 20 degrees. That is how you would locate Jupiter in the night sky. That is the coordinate system in practice, right? And you can do that for anything. I'm kind of curious. You can actually see Orion right there. That's kind of cool. I didn't think you'd be able to see it on camera. Something, actually, I'll get to that later. But, yeah. Going back to my telescope. What I'm going to do is that I'm going to look at something and then cut the video to the next thing. So that way, because you can't really see what I'm doing as I'm doing it. So the first thing we're going to look at is Jupiter. Alright, so here is Jupiter. It kind of might be hard to see, but that's the dot going across the screen. I'm not moving the telescope. That is the Earth rotating, so I mean, that's kind of cool. There is kind of a dilemma with Jupiter, although, let me move it back to the center for you. Although, if you look closely, it is very vague, but you can vaguely see the stripes on it. You might have to zoom in to see it. But they're there, I promise you. And they're actually going up and down because relative to Jupiter, we're actually slanted 90 degrees, so that's kind of fun. Let me put it back in the center for you. And there's always sorry, put it back in the center. And there's always a dilemma with Jupiter, because although you can see it good, right? If I mess around with the settings, you can vaguely see the bands. But here's the thing: if you underexpose the image, you can see the bands on Jupiter, but you can't see any moons because they're too small. But at the same time, if you overexpose the image, like what I'm doing right now, you can now see the moons. If you see the dots next to it, that is Io and Europa. The closer dot is Io, because it's a it's basically a giant hot rock. You see another little moon, and then Europa is the further one away, right? So you can only really see the moons or Jupiter. You can't really see both when you're filming. So so that's really cool. Yeah. Let me put the exposure back down for you guys so you can see Jupiter again. And yeah, I'm gonna go look at my next target, which is gonna be the Great Orion Nebula, and I'm really excited for that, so see you there. Alright, so here is the Great Orion Nebula. Sadly, you can't really see the gas. I tried putting on a filter so that way you could see it better, but it didn't really work. But here is the nebula. The gas should be where the brightest star is. I know I have it pointed at it, so I'm gonna have to find a new way or research something that would do that. But yeah, it's still cool. It's still pretty cool to see all the little stars and twinkling. Um, so because this didn't really work, I'm gonna look at Betelgeuse. We're gonna look at that, and so we can actually see the contrast between the red and blue star. Actually, wait, no, I'm just gonna move it right now. That's what I'm gonna do. So I'm gonna move the telescope, moving it. And okay, there we go. That's Betelgeuse. Isn't that cool? Look how red it is. Let me put it in a better focus for you guys to see. Now this star is actually really big because it's a red giant, right? And what I told you earlier is that it burns slower, but it burns for longer, right? And it's also physically bigger. And this is, you're actually looking at the star. It isn't just like a dot. Like, you can actually see the circle of where the star is, like the actual physical object. So, that's pretty cool. See the little streaks coming from it. Yeah. Now, I'm going to point it at the other blue star in the Orion Nebula. It's right next to it. I forget its name. They all have Greek names that I can't remember. But nonetheless, it's a blue star. So, point it at that. There we go. Blue star. Blue stars are blue stars are smaller, but they burn harder, but for less time. That's the trade-off, right? And yeah, you can really see the contrast between the two. Generally in astronomy, these things look so much better in person, but it's still pretty cool to see them probably from the comfort of your own home. So yeah, now I'm gonna point the telescope at Pleiades. What Pleiades is that it is the biggest star cluster, not cluster, actually yeah, biggest, closest star cluster to us. And from on the ground, it kind of looks like a mini Big Dipper. I wonder if there's other like astronomers that think that too. But yeah, okay, I'm gonna point it. Here is Pleiades. Let me zoom out so you can see better. No, wait, that's in. One second. I'm sorry. This is hard. Honestly, even though this isn't like the most high quality video, I'm still really impressed with myself that like I'm coming out here, because I see a lot of astronomy things online, but I don't see many people actually going outside and looking through a telescope. So yeah, really cool. Really proud of myself. Anyways, that's, well, looking at the night sky. Although this is called the actually wait, no, never mind. I'm sorry. Random thought. Yeah, I hope you enjoyed watching, and I'll see you in the next one.